Yeah, welcome on DataOps Poland. Today it's meetup with Alicja. Thanks for our sponsor Adform, who is sponsoring this event, and the book will be sent to one of the attendees. So that's all from my side. Alicja, welcome, our queen.
So that's the title that I do hear like the first time in my life, but thank you. This is like sounds really nice. So
I'm glad that
yeah.
because if you don't know Alicja is the super active person about the Postgres. She is the organizer as your founder of Warsaw Postgres Group. Also, if you know any most of events with Postgres, you can find Alicja as a speaker, as an organizer, or as attendance or whatever. So
yes,
yeah,
I'm always there. Yes, that's the truth. And
exactly.
I also like to introduce myself as the Postgres song producer. So, because I produced like 2 songs, like Postgres songs. The first one was about the vacuum. The second one is about explain, analyze. So I'm also like the Postgres song producer. Okay, but yeah, thank you actually for mentioning like that we worked together. That was like really, I would say, like really interesting company with really interesting work culture, I would say. But and it was actually my first job in IT. So yeah, that is something that I do remind really like yeah, pretty warm. Okay, so my name is Alicja Kucharczyk. I'm currently working as EMEA Global Black Belt OSS Data Specialist at Microsoft. And actually the technology that I will be talking about, the company actually which developed this technology was acquired by Microsoft. So they are actually now the Microsoft employees. But of course, Postgres cannot be acquired. Postgres cannot be bought. So this is really important thing to remember. Postgres is open source, is free to use, and really it will stay like that, I believe, forever. I hope it will live forever. There's even a talk like, will Postgres will live forever? So I absolutely do hope so. Just a quick question. How many of you have ever used Postgres? Like maybe thumbs up, like just to, to give me like the overview. No one?
You can write on chat if you can unmute. So
we've got like 5 likes, I think.
Okay, cool.
I see a couple of thumbs up.
Okay, I see it going. Okay, so as you might know, or you might seen recently, that Postgres is actually the fastest growing database ever. Like for a couple of years, there is no database that is growing faster than Postgres. It's still not the most popular database in the world, but probably looking at the stats, it will soon be one. I'm also just as the side note, I'm normally doing at my job, I would say 80% of my job is Oracle to Postgres migration. And it's huge enterprises migrating the whole stack from Oracle, thousands of the databases, the whole Oracle databases they've got in their data center to Postgres to the cloud. So it's really the huge motion. If you haven't seen yet this, or you are not familiar with Postgres, it will probably hit you sooner or later. So Postgres is, as I said, this open source, free to use data platform, which is super rich data types. Super rich selection of them. If you are installing Postgres, you've got over 80, just out the box. And with the extensions, you will have much more. And about the extensions, this is also something that Postgres is really famous from The Postgres core, it's really small and of course super efficient. But if you would need some specific features, some specific capabilities, there's always an option to add an extension. And you've got like thousands of extensions up there that you can choose from. Of course, we've got like set of them that are really super popular, like PostGIS. There are some extensions like which are just offering you some functions which are less popular, but the main idea is that you are not limited to what you've got like in the pure core of Postgres. The second feature I would say like that made Postgres really popular is JSON-B, which is kind of, you can think of that like the native JSON type, which is this B stands, like some people say, like for brilliant, but it's actually binary. So it means that the JSON that you've got, it's actually parsed. It's like transformed to the binary form. White spaces are removed. Like there is like key duplication also removed. But for like at the end, you've got a really effective engine to work with JSON data type. Also, like you've got separate set of indexes to work with them. Yeah, and basically, if you do compare Postgres features with the features of some proprietary databases, like without the names, of course, you will find that there is almost like no gap. Almost, of course, like each engine has got like some specific features, but you can absolutely compare Postgres not only because of the price, but also because of the feature set with the proprietary ones. And what is Hyperscale Citus? Because it's basically the topic of this talk. So this is an extension. So again, like PostGIS, like this geographic thing, like a small extension which just gives you like the set of some functions to do, for instance, some calculations. You've got this really powerful extension that you are just adding to your Postgres core, and suddenly you are changing your Postgres into the cluster of many machines, of many nodes. And it's an extension, so you don't lose, for instance, the capability of like having JSON-Bs or adding another extensions. But you do gain like the ability to scale almost like infinitely. Like, of course, like there's, I don't know, cluster which has got like 1,000 of worker nodes, but yeah, I do know like the cluster with 60 with 100 worker nodes working together. And this is turning Postgres into distributed sharded database. So something that that was more, I believe like the sharding, the word sharding, it's much more, it's got bigger affinity with NoSQL databases, right? With the normal relational databases, not that much. But absolutely, like by adding this extension, you still like have this ability. You've still got like the full ACID compliance, plus you've got the sharded database. Okay, so there are some use cases where like Citus, it's not like great fit. Like it will not always be the solution for your problems. But we do have like the use cases where Citus works really well, like with some kind of analytics together with OLTP workload. If you mix those two, we to call it HTAP, like probably the new buzzword that you might hear. Another one would be like multi-tenant or SaaS application. So when you can like divide your data model by using customer ID, tenant ID, shop ID, whatever. And also like with the classic OLTP applications, because you still have like strong consistency with the Citus. And maybe a bit about the beginnings, because I believe that the story is really interesting. So as you probably know, Microsoft is producing this operating system, just forgotten the name, it was something with doors or something, right? So there's like around like 1 billion devices. There's like now around 1 billion devices in the world, like with Windows operating system. And some of these devices, of course, not all, you can turn it off, but do send telemetry to one big database. And and this system, as you might already like suppose, it's pretty big, right? With those 1 billion devices and all the telemetry data. So yeah, some performance problems like started a couple years ago, and the principal engineer, Minwei, like was just driving home, was listening to the recording in the car, and he heard about this weird thing called Citus, and like he said, okay, maybe let's give it a try. And actually, after giving Citus a try, like doing the POC, like a few months later, Citus Data, so the developers of Citus extension, were acquired by Microsoft. And actually, like now, this database is using Citus, and it's around like 2 petabytes of data. And as you see up here, still the response time of like the majority of the queries are like milliseconds. So pretty much impressive. So how this Citus really works. So we've got, at least on Azure, because Citus actually could be like, the extension can be downloaded just for free. You can use it like on-prem, totally without any fees. So it's again like free software. But you can use it on Azure as a PaaS, and then you've got always one coordinator. I'm telling you that because like on Prem, you can have multiple coordinators if you really need that. On Azure, currently in the PaaS offering, you've got just one coordinator. And the coordinator is the Postgres instance that is basically holding the metadata for the whole cluster. And then you've got multiple data nodes. On Azure up to 100. And each of these data nodes or worker nodes, those two names are fine for the data workers, are also like separate Postgres instances. Okay, so we've got like one Postgres instance, which is coordinator holding the metadata for the cluster. And you've got data nodes, which are the Postgres instances that actually do store the data from your database. What's sharding? This is the process of dividing data among nodes, like putting them like in small chunks. Pretty much as partitioning. This is kind of similar one. I always like think those two are kind of similar, but sharding has got this difference that you put the data on different nodes. Okay, not in one Postgres instance, on many nodes, many Postgres instances. And shards, you can think of them as normal Postgres tables because they are physically like the normal Postgres tables. And like the thing in the coordinator node, like coordinator node taking like this huge table, splitting this table into small shards, so small parts of the data, and like putting those tables on different data nodes. Okay, so as I said, still we do talk about the sharding, about the cloud. So like probably the first like word that comes into mind is like NoSQL solution, right? But Postgres, not Citus yet, has got a built-in two-phase protocol that was kind of designed for those purposes. So Citus is leveraging this two-phase protocol. So you can be sure that once you've got the transaction committed, those data will be there. There is no such a thing like eventual consistency or something similar. And comparing to normal Postgres, there are of course like some kind of some differences. For sure, like before even thinking of migrating to Citus, you need like to do analysis if that's really good fit for Citus, if we will be able like to find a good distribution key, if the data model will be a good fit for Citus cluster. And basically then what we are doing is just thinking which table should be of which type, because we've got basically 3 table types, and it's really crucial to decide which table will be distributed, which table will be referenced, which one will be local. And distributed tables, those are those really huge tables. For instance, if you've got like 1 terabyte table, if you've got 200 gigabyte table of really big sizes, that will be splitted into smaller chunks, those shards. You can think of it like the common examples are like transactions, events, orders, right? So those kind of tables when you really have a lot of data that you're operating on those data. And to make your table distributed, there's one function in Citus, which is create a distributed table. You are just giving to this function as the first parameter the table name. So for instance, the orders, and column name will be your sharding key that you really need to think which one it should be. And then what Citus is doing, it's splitting this table into chunks. By default, there are 32 chunks, and then putting them on the data nodes. Okay. The second type of the tables are reference tables. Those are not splitted. Those are like kept like as a whole in each data node. Why? Because sometimes you've got, for instance, dictionaries, right? Like the dictionaries with, for instance, countries, with categories, with currencies that you commonly join your tables with. So probably you don't want to shard them among the nodes. So you don't want like to keep those data separated, splitted among the nodes. You probably want like to have the full set of data on each node. So those tables are defined with this function, create reference table, and you're just putting the name of the table after. And the third one, which is probably not that fancy as the rest, this is local tables. Actually, it's commonly happening when you just forgot to use one of those functions, like create reference table or create distributed table. Then just your table lands on the coordinator node. It's not sharded, it's not replicated among the nodes. It just, laying there on the coordinator node. Probably the tables that are the part of the business logic should not be placed there. It's more for like maintenance tables. I would say, like if you've got a system that is like that is saving all the changes, the DDL changes that you are doing to your database, like with the date, with the patch number, and so on. And then probably that's the good one, because you don't need to share this data. You don't need like to have it on each node to do the joins. Like if those are like kind of the maintenance tables, then okay, this is probably good to go. Okay, what is also cool, that we can collocate in Citus. It means that if we have, that's the example with the site ID, yeah, we can like use it. So we do shard our data models using the site ID column. And for the data that has got the same ID in this column from couple of tables, those rows will be placed on the same worker node. What the advantage of that? The advantage is mostly that your queries, your joins, will be done just on one data node. So there is no movement between the data nodes. You are just doing the query on one node and then just returning the result back to the coordinator. Because yeah, you need to remember there is like, those are like separate instances of Postgres. Those are normally like the separate VMs. So there is also like the network up here that you need to like count in. Okay, so on the Azure also, we have this cool thing like let's say Black Friday thing. You are able to just add nodes if you've got some peak in your database, like the high CPU load, like some kind of problems with your performance. You're adding the nodes, and this is done pretty much automatically. It means like there is like Postgres logical replication used to move the data to new nodes. Then like the data in the coordinator node, so the metadata of the cluster are changed. And since then you are able like to use more nodes than before. So this is done pretty much smoothly. And as I said, this is like totally free extension. You don't have to pay for the usage. If you would like to have like fully managed database, then yeah, Azure would be the cloud. We've got like the HA like out of the box. We've got like some performance optimization done by the Citus team, and it's just fully managed. This is how the minimal Citus cluster looks like. So you've got the coordinator node and you've got at least 2 worker nodes. Yeah, again, on Azure, because normally you can have like, for instance, 0, right? Just if you're adding just the extension to one Postgres instance, then you've got like at first like 0 nodes. And what is also important, like you don't need to make your application aware that you don't use normal Postgres, but you are using like the cluster of Postgreses. Because you are using to coordinator node and application sees it like just a normal Postgres instance. And it's the job of the coordinator to like use the planner to effectively like split your query among the worker nodes. And this is how HA is basically done on Azure. So you've got like the second cluster of the of Citus, which is connected with this time physical synchronous replication of Postgres. Of course, the fully automated mechanism of like doing the health check, and in case of failure, there is like the automatic failover. Yeah, okay. I wanted like to keep it short. Yeah.
Can we? Because we have like questions.
Yeah, okay. Absolutely.
So the first one from Paweł Suchotki, the question is, Alicja, do you also do migrations from SQL Server to Postgres?
So I would love to, not yet, but I would love to. I'm so busy now, like with Oracle migrations, like, you know, if you've got like the job, like for one company, like to migrate 800 databases, and then like from another company to migrate like 1,400, then you really don't have time like to think about other migrations, but I would absolutely love to do that, yes.
Okay. Just to make sure, you already finished the presentation, right?
Mm-hmm.
Okay. So, Łukasz, you can ask directly this question you've right. Just let me read the next one, okay? So the next question is about sharding of databases tables. It's equally has relations affinity with MySQL?
Yeah, so it's a good question. So maybe I will share again, but I will show you my amazing drawing skills, okay?
We just opened the back with the questions.
Okay. You see paint?
Yeah, we see it.
Okay, cool. Okay, so
now
my
we know
amazing...
you work in the Microsoft.
Right. Actually, I needed to learn how to use Windows after like many years not using it. So that was really cool. Okay, so basically, let's say this is worker node 1. This is worker node 2. And you've got this 32 shards, right? Because by default, there's like 32 shards. So they are like splitted, like if you've got 2 worker nodes, they are splitted simply like that. If you've got 4, there's gonna be 8, right? But you can absolutely also change this number if you think it's like too big, or if you think it's like too small. You can absolutely do change that. But remember, just if you've got like less, then it's kind of like your limit in the worker node count, right? Because then you will not be able like to just use more power, more CPU, more RAM, like that you would have like by adding additional nodes, right? Because there's been no shard like to place like on the additional worker node. Amazing drawing skills, right?
Definitely.
Yeah, I agree. 10 points out of 10.
Thank you. Yeah, hope this answers the
maybe
question.
9 because you didn't use colors.
Oh, sorry.
Much better now.
Thank you.
Okay, next question. What about coordinator high availability?
So basically the whole cluster has got like its mirroring, right? Like mirror side. So together with the coordinator.
Okay, so we can cover it behind, let's say, some load balancer, console or whatever, right?
Basically, you can, like if you're, because, you know, there are like 2 like different modes, right? One is Azure PaaS, the second one is on-prem. So on Azure, that is like warm standby, right? This is not hot standby, this is warm standby. But basically, if you are like having that like on-prem, that's like actually your call.
The standbys can work with read operations.
Sorry?
These standbys can handle read operations for cluster?
Yes, so basically you need to treat it like each node together with the coordinator, like, you know, as just standard Postgres instance.
Oh, okay.
Cool. So are you good, Łukasz?
Yes, perfect.
Okay, the next question, Robert. Is Citus with enterprise support available by any other cloud provider like AWS, GPC after the Microsoft acquired it?
So it was, yeah, that's good catch. So it was, but you know, when we acquired them, like they kind of stopped, of course, developing on other clouds. So it's not anymore. So the existing customers are still supported, but we do not like take any new ones.
Robert, it's good. Are you okay, or you need more
Yeah,
explanation?
very good. Thank you. That answers my question.
Yeah. Okay, next question. Do we need to make any changes in the application when we move to Citus?
So would say no if you will do the job with data modeling. So I know this answer isn't like the full one, but basically, like if you've got like the if you have analyzed like the data access patterns in your application, and you've got the column like which is used with like 90% of your queries, then I would say no. If you don't have it, then you need to like include this column in your queries. And we've got actually like for most popular framework, some kind of tools that kind of inject like this column like to your queries.
Okay. The next one, let me see. From Boris, what kind of limitations Citus has? Is it similar to Redshift?
I don't know Redshift, so you know.
Okay, so limitations.
Okay. So actually, we do have now like columnar storage, so absolutely can be used as one. But I believe that the main limitation would be if you've got like if you've got the database where like your main problems are logs, not logos, but logs, right? And you've got really high contention of the logs, that will probably not solve your problem because you will still have those logs, but you will also like add the network latency to it. So that will not solve anything.
Okay, great, thank you.
The next question from Pavel. Maybe, Pavel, if you can unmute yourself, because I can bet there is something behind your question and some story. So if you can provide a little bit more and elaborate, it will be perfect. Can you? Oh, okay. So just unmute yourself. Oh, we see someone, we hear someone, but it's not you, probably. Okay, maybe I will read. Do you know in which scenarios we can use Citus above standard Postgres partitioning with the clustering in Kubernetes? With example, probably. Example clustering in Kubernetes.
Over the standard Postgres partitioning, right?
Yeah, exactly.
Like I would not say those two are like excluding each other. And actually we are sometimes like doing both. So if you've got like really big data set, like many terabytes, like tables, then like we for instance, like using the classic Postgres partitioning, like to partition by date, and then we are using tenant ID like to shard. So then you've got like instead of 1 terabyte tables, you will have like, depending of course on the ranges that you use, but you will have like a couple of hundreds of small chunks like put it on different nodes. Of course, if that makes sense, like from your application perspective, if you do have that, you know, the queries that do use like these columns like in the where clause, right? But for those of you, and I know that there is like a couple of people like on this call that do know Postgres, of course, Tomek and Pavel also. So you probably had this situation where like the shared buffers was really struggling to get data right inside, and there's been like context switch like on the CPUs, etc. And this is like often like caused by those huge tables that needs to be pulled in shared buffers, right, in order to be read. And like if vacuum is like doing something on a really huge table, there is also not a good one, right? So if you've got like smaller data chunks, it's really you can see this performance impact.
Cool. Before I read the next question, I would say I also use the Citus. Alicja, my pronunciation Citus, right? Or it's Citus?
No, that doesn't matter. Actually, like a lot of people do say Citus, a lot Citus. There's like a lot of that. It's not like Postgre and Postgres. So you can be sure it's like you can really like use both.
Okay, so I also had a little bit experience. I had the 2 clusters with like 4 nodes or something like that. And to be honest, I was surprised how fast is it. And about the limits, I didn't notice any. Nothing like PG pool, and you can use some SQL commands. There is like, I mean, Citus is like just you fire up it and it works without any problem.
Yes. Yeah, you know, you will find some limitations. Of course, it's not perfect, but yeah, I would say like in performance wise, I did like many tests with data loading, for instance. It's really amazing, yes. And you know, in most of cases, you don't need like the low, like, you know, load balancing, to be honest, because like Citus like is doing both, like scaling your reads and writes, like both, not only reads, like you've got like with the classic setups with the read replicas.
Okay, so the next questions, adding new shards online are possible?
So yeah, so basically that's the part of the process that I was talking about. So of course it is, but also like you need to keep in mind like there's like some data shuffling. So it's also not like totally transparent, but yeah.
Okay, sorry, I missed the question. So back from Emmanuel, our session migrated between coordinators or if mirrored? I think like it's not losing the connections, right? If I got the question. Are sessions migrated coordinators? So I think that's one is the master, second is standby.
So it's just, you know, if you've got like 2 clusters, like warm, hot, standby, whatever, then that will act as normal Postgres. So you will lose like the session, yes. There's normal like process of disconnection and connection to the new primary.
Okay, Emmanuel, if that's fit for you, let us know. If you have more questions, also we are open. Another one question that I missed: what other plugins available for Postgres, and how Citus is different from others?
Oh, so about the plugins, I'm not even sure like which one to start. Actually, there are so many. So maybe pgcron, which is job scheduler. You've got the pgpartman thing, which can automate your partitioning, which is really cool. It's kind of when I'm doing the migration, like actually I can like, completely delete most of the procedures for the maintenance because I've got PG Partman. What else? Fuzzy string match, I really like. Yeah, it's thousands of them, to be honest.
Okay. So the next question from Mirek. If you set date as chart key, all dates are randomly spent on all 32 chunks, randomly.
So dates I mentioned as the partitioning key, not as the shard key, because like basically, like in 90% of the cases, like date is not a good sharding key. It is sometimes, like always depends on the application, but what we normally do, like it's partition by date and then shard. So you've got like kind of 2 layers of complexity.
Mm-hmm. So I think that's all.
I have one more question, if I may.
Sure.
No.
Maybe. Maybe it's more for Tomek. You said that you have Citus in your 4-node cluster, and you didn't notice any, performance degradation. Can you share what's your use case for the application? Is it more like OTP or is it like analytical?
It's more about like OTP, I would say. We store. It was how to say, at the beginning. It was the just MVP of some product, and the stories behind that, it's pretty long. I joined in the middle of this project. Then I work with the Citus a little bit, and finally the project was closed, but not. I mean, the reason was not in the data or the technology. Just the guys with the C in the name, in the C level, decided we choose some different path to create the products, but technology itself, it was pretty good one, at least for me. And it was pretty. I have the background like Alicja. How many years? 10, 15? How many? When we met
Yeah,
first time.
something like that. Wow, yes.
So,
oh my God.
so exactly that's my background of the PostgreSQL. So I have no problems with it at all. I spent like 2 or 3 hours just reading about what Alicja shows today. I mean, that coordinators and all the stuff, but in general, it was like super easy and really really good technology. I would say no big deals and no big issues.
Okay, but did you use the licensed version or did you use the free version available from Citus?
The free one. I mean, the open source.
Okay.
If you're asking about the numbers, it was like the VMs was something around 60 gigabytes RAM each of them, like 32 virtual cores each, and there was something about like 500 gigabytes all data, something like that.
Mm-hmm. And do you know whether the free version of Hyperscale still have those limitations regarding resharding? Because I was testing that some time ago, and I remember when you use the free extension available as the open source, it's not possible to reshard when you actually decide on doing something. Then you cannot change it. I mean, this feature was available in the paid version, as far as I remember. So I don't know if it's still the same approach, or is it allowed to use it in the free version?
For me, it's hard to say because I work with many technology, and like I said, it was some only some part I'm not doing right now. So I have experience, but not doing right now. So I can tell you, and I don't want to lie at all.
Okay, so maybe one last question. Do you think is it possible to utilize or use Citus as some kind of, let's call it Kubernetes in terms of databases? So let's say we have a, let's assume 32 nodes cluster, and we can treat it as a platform, let's say, for spinning up databases and then moving them across the nodes, or is it more like strictly for sharding tables?
I don't think. I'm not sure. First, like if I do understand like fully your,
are you familiar with Kubernetes and the pod thing?
A bit, yes.
Okay, so let's assume a database is a pod, and is it possible to use Citus to spin up the databases like pods in Kubernetes and place them, let's say, on node number 1, and then you spin up more databases, and you can place them on different nodes, but you still have, let's say, a single entry point, and then you can just jump between the databases.
Like the cluster, it's basically one thing. Like it's not like Kubernetes when like one part will die, like it will like be spin up like the other one and so on. It's more like the, if one part, like one worker node will die, then your cluster dies.
Okay.
I'm not sure if I put it that right.
Okay, for me, because I'm just Googling and I see that 2016 there was, people start writing about it, and I can bet that Citus already supports the Kubernetes because I see that discussion like 5 years ago. They already supporting the Kubernetes. And
what I meant is whether you can treat Citus as a Kubernetes, not working with Kubernetes. It's more like treating as a platform on which you can spin up, databases and then move them across the whole cluster. Just like in Kubernetes, you can set up a cluster within.
It's shared nothing architecture. So it's
Yeah, sorry. So can I add one line? So this is Subhashish actually.
Yeah, sure.
Yeah, so I work with the Citus team quite a lot actually. So I'm part of Microsoft. So no. So what exactly you are meaning, right? That is not possible because here the tables are logically sharded into partitions. Very, very different concept from Kubernetes. So there is no concept of pods here. So I'm taking the table structures and logically sharding. So try and understand. So logical sharding is happening as a modular block architecture. So that's the entire concept. Then it has worker nodes, but it is not the concept of AKS. No, absolutely not.